Hello, this is Ms. DB, and today we're going to talk about conditions for special parallelograms. So in the previous lesson, you learned that if you have a rectangle, a rhombus, or a square, then certain properties will be true. In this one, we're going to try to figure out, do we have a parallelogram, a rectangle, a rhombus, or a square given what we know about it? All right, so first one we're going to talk about is rectangle. If you have a parallelogram and one angle is a right angle, that's enough to know that the parallelogram is a rectangle. So first of all, to be a parallelogram, opposite sides have to be parallel. And then if you have one right angle, then you know it's a rectangle. In the second theorem, if the diagonals of a parallelogram are congruent, then the parallelogram is a rectangle. So again, if you know it's a parallelogram, and then you are given that or you can show that the diagonals are congruent, that's enough to say that you have a rectangle. So here's an example. We have a desktop, and just look at the rectangle, or the shape at the top. We don't know if it's a rectangle, but we want to say, why will it be a rectangle? So I'm just sketching this again. A, B, I don't want to do the 3D thing. And angle B we know is a right angle. We do know that AB is congruent to CD and that BC is congruent to DA, which means that it is a parallelogram, because one of the things in order to tell if you have a parallelogram is if opposite sides are congruent, then you have a parallelogram. Also, we are given that angle B is a right angle. So by the two different theorems here, one from section 3 and then one from this section, we know it's a parallelogram, and then we know that it's a right angle, so therefore by theorem 651 we know that this is a rectangle. Okay, here's another one. A carpenter's square can be used to test that an angle is a right angle. How could the contractor use a carpenter's square to check that the frame is a rectangle? So if you know that you have a parallelogram, which you can figure out if if both pairs of opposite sides are congruent. So you can measure and make sure that this is congruent to this, XW is congruent to YZ, and you can also measure and make sure that XY is congruent to WZ. That's enough to say that you have a parallelogram. Then you can use your carpenter's square, which looks like a little triangle, and you put it in the corner, and if the edges of the legs of the little right triangle fit exactly into this space, then you know that this is a right angle. And if this is a right angle, then you have enough information to know that you have a rectangle then. Or I guess you'd put the square right here. The carpenter's square is actually a triangle shape, but this is a square corner here. All right, so we have some more to determine if you have a rhombus. All right, if you have a parallelogram and one pair of consecutive sides are congruent, then the parallelogram is a rhombus. So if you know you have a parallelogram by whatever means needed, and you know that two sides that are touching each other, consecutive, are congruent, that's enough to say you have a rhombus. Okay, there's another theorem that says if the diagonals of a parallelogram are perpendicular. So again, you need to know it's a parallelogram by whatever means, and then if you know that these two diagonals intersect at right angles, that's enough to know you have a rhombus. And finally, if one diagonal of a parallelogram bisects a pair of opposite angles, so if this angle is congruent to this angle and this angle is congruent to this angle, then you know you have a rhombus. And again, you have to start, all of these have to start with knowing that it's a parallelogram. You have to determine that first if they don't tell you. All right, so for a square, you're going to show that it's a rectangle and a rhombus. A square is a rectangle and it's a rhombus. You can also prove that a given quadrilateral is a rectangle, rhombus, or square by using the definitions of special quadrilaterals. All right, so let's check and see. They're telling us that EF is congruent to FG. Where's FG? FG. They also tell you that EG EG here is perpendicular to FH. That means the diagonals are perpendicular. And the question is this a rhombus? All right, so first of all, we have to determine if it's a parallelogram. Is there any way to tell if this is a parallelogram? It could be a parallelogram if opposite sides were congruent. If you could use a definition, and if you were given that opposite sides were parallel, but we're not. We're not given opposite angles are congruent. We're not giving opposite sides are congruent. So if they had just said that this was a parallelogram, we'd be able to move on. But we don't know. We have to know that this is a parallelogram, and that information was not first given to us. So we don't have enough information to make this valid. So what additional information? We could be told that opposite sides were congruent, like EF is congruent to GH. We could have been told that opposite angles were congruent. We could have been told that opposite sides were parallel, but we didn't have any of that information. Basically, we needed to know that this was a parallelogram first. All right, let's see about this one. We are given that EB is congruent to BG. That means that it was bisected. We also are given that FB is congruent to BH. So we do know that the diagonals are bisecting something. Also, we know that EG is congruent to FH. Okay, the diagonals are congruent to each other, which means that if they've been bisected, I could do this. So the diagonals are bisecting each other, and the diagonals are equal to each other. So first of all, we are going to determine if it's a parallelogram. Also, we're given that EBF, triangle EBF, is congruent to triangle EBH, which means that all parts are congruent. That's very handy. All right, so we're given those things, the segments being congruent that I already have marked. So we know it's a parallelogram because it's a quadrilateral with the diagonals bisecting each other. That's one of the theorems that you learned about in 6.3 to determine that it was a parallelogram. So that's good. Now we have to see if it's a rectangle. We know that EG is congruent to BH. That means the diagonals are congruent. Therefore, that's enough to say that you have a rectangle. And then to determine if it's a rhombus, we do know that the two triangles are congruent to each other. That was given, which means that all their corresponding parts are congruent. And that means, I'm going to go back to the picture. I wish the picture was here. Because triangle EBF, this triangle is congruent to this triangle, it means all their corresponding parts are congruent, which means that these two sides are congruent to each other, which is one of the parts to be a rhombus. If two consecutive sides are congruent to each other, then you have a rhombus. Now, to determine if it's a square, we need to have that it's a rectangle and a rhombus, and it does. And that, therefore, it's a square. You don't really have to say, therefore, it's a square by definition. You really just have to say it's a rectangle and a rhombus, therefore, it's a square. All right, let's try one more of these. We have that angle ABC is a right angle. ABC, this is a right angle. Oh, where'd it go? ABC is a right angle. There we go. And then you can say that it's a rectangle. Is that enough? Well, it's only true if we have that it's a parallelogram with one right angle. We are not given that it's a parallelogram first. We have to know that it's a parallelogram by any of the methods you learned about in 6.3. We don't have enough information. All right, now we're going to move on. We're going to say if you have these vertices, can you tell if it's a parallelogram, which they're telling us it is, a rectangle, a rhombus, or a square? So if you can't figure out any of them, you just say parallelogram, since they said it is a parallelogram. So what are you going to do? You're going to plot these in a coordinate system. So draw it out. Now that is not enough. Just drawing it and saying, hey, that looks like a square, that is not enough. Or saying, hey, it looks like a rhombus. You have to figure out if it's a rectangle or a rhombus, and if it's both of them, then it's a square. All right, so we need to figure out if it is a rectangle. It's a rectangle if opposite sides are congruent and you have a right angle. All right, so we are given, or we can find with the distance formula. Let me do it on this page here. P is -1, 4. This is P. Q is 2, 6. R is 4, 3. And here's S. So if opposite sides are congruent, it's a parallelogram. It must be. That must be true because they said it is a parallelogram. But let's work this out. So this is -1, 4, 2, 6, 4, 3. And you can do this on your own paper. You don't have to try to do this in the Word in the worksheet. Or you can do it in Sketchpad and be even quicker. So we want to find this length, and we want to find this length, and we want to find this length, and we want to find this length. You can do that with the distance formula. The distance formula says that you are going to take the square root of, and then you subtract the x-coordinates and square it, and you subtract the y-coordinates and square it. Okay, x minus x would be -1 minus 2. That would be -3. And y minus y would be 4 minus 6 would be -2. So I'm going to take the square root of this. This would be 9 plus 4, so the square root of 13. I'm going to do the same thing down here. I'm going to take the square root of x minus x would be 1 minus 4. That'd be -3 squared, plus 1 minus 3 would be -2 squared. This touchy thing. So I would get the square root of 9 plus 4, which is the square root of 13 again. So these two sides are congruent. Okay, now let's check the other two sides, PS and QR. To do these two, I'm going to take the square root of x minus x would be -1 minus 1. That'd be -2 squared. And 4 minus 1 would be 3 squared. Let me just double check I did that right. -1 minus 1 is -2. 4 minus 1 is 3. So I'd get 4 plus, this is the same thing. So I get the square root of 13. And then this side, so these are the same as this. And then this side, I bet, is going to be the same thing, but let's check. 2 minus 4 is -2 squared. 6 minus 3 is 3 squared. Same thing. I get 4 plus 9. I get the square root of 13. All sides are the square root of 13. All sides are congruent. That's enough for it to be a rhombus. All sides being congruent. Let's check the slopes. This slope here is rise over run. From P to S would be 1 minus 4. That'd be 1, 2, 3 over 2. And it's negative. That's the slope of -3/2. Let's check this one's slope. It has a rise of 6 minus 2. 3 is 3. 2 minus 4 is -2. Also has a slope of -3/2. These two are parallel. Okay, let's check opposite sides. All right, so this one has a slope of 2/3. This one has a slope of 2/3. So these are also parallel to each other, and 2/3 is the negative reciprocal of -3/2. These are right angles. Okay, so we know it's a rectangle because it has a right angle. We also know, well, we already knew it's a parallelogram. We know it's a rhombus. So that is enough to determine it's a square. It's a rhombus. It's a rectangle. How did they get the square root of 26? Did I make a mistake on mine, or are they using the wrong numbers? I think they're using the wrong numbers. Yeah, these are different slopes that I have too. I must have copied the wrong question, or the answers to the wrong question. So we'll just go with what I had written on the screen here. I must have messed that one up. So it is a square. It is also a rhombus. If it's a square, it's a rhombus, and a rectangle, and it would also be a parallelogram. So these are for different points. All right, this one says to use the diagonals to determine whether a parallelogram with the given vertices is a rectangle, rhombus, or square. Same kind of problem. We are going to graph it, and then you're going to determine the slopes and the distance. Now, It doesn't look like it's a square or a rectangle, right? Because it does not look like a right angle. But let's check that. Let's check the slopes first this time. If I find the slope of this one right here, the slope is rise over run. So 1, 2, 3, 4 over 1. This one has a slope of 4. This one over here also has a slope of 1, 2, 3, 4 over 1. This one has a slope of 4. They have the same slope, so these two lines are parallel. Let's check the slope of the other two lines. This one has a slope of rise of 1. Oh my goodness. Stop moving. This one has a slope of 1 over 1, 2, 3, 4. One-fourth, and this one has a slope of 1/4. Now you might say, wait a minute, those are opposite, but they're not negative. They're all positive slopes. So it's not perpendicular. Some have a slope of 1/4, some have a slope of 4. So opposite sides are parallel, but not perpendicular. So this is not a rectangle, and then it's not a square. Now we got to see if it can still be a rhombus or not. To determine if it's a rhombus, we need to see if consecutive sides are the same length. So that means that we have to determine the distance formula of the point here is -1, -3, and I'm going to use this point of 0, 1. So I take the difference in the x value and square it. So 0 minus a -1 is 1 squared, plus the difference in the y value squared would be 1 minus a -3 would be 4 squared. So this would be 1 plus 16, which would be the square root of 17. Now let's see if this one has a length of square root of 17. So this was the point 4, 2. Okay, so the difference in the x values would be 4. The difference in the y values would be 1 minus 2 would be -1 squared. So that is 16 plus 1, which is the square root of 17. So this side is congruent to this side. That's enough right there to know that we have a rhombus. We have a parallelogram. We determined that because opposite sides are parallel. And now we have the consecutive sides are congruent to each other. So we did determine that it was a rhombus. We did it a different way. All right, now this is part of your worksheet. If you're watching this video, you'll get a little sneak peek. It says, write the name of the quadrilateral that best matches the information. You can choose from rectangle, rhombus, or square. They're all parallelograms. You want to choose the most specific answer you can. So if it's a parallelogram with one right angle, does it have to be a square? No, because in order to be a square, we also need to know that the sides have equal lengths, and we don't have enough for that. But we do know that it's a rectangle. Okay, a parallelogram with, the second one, number 12, the only box that's marked is this one, parallelogram with a diagonal that bisects a pair of opposite angles. So a parallelogram with a diagonal that bisects a pair of opposite angles. So if you look back at your theorems from this section, I'm going to go back to a different slide here so I can show you. It bisects, was that in this one? Bisects a pair of opposite angles. That was 655. If one diagonal of a parallelogram bisects a pair of opposite angles, then the parallelogram is a rhombus. So right here, that's exactly what this says. So number 12 will be rhombus. Okay, number 13 has one right angle and it bisects a pair of opposite angles. Well, we just learned that if it bisects a pair of opposite angles, it is a rhombus. And we already, let me go back to the theorem that says if it has one right angle, then it's a rectangle. So for number 13, you know both of those things are true. This one we can say it's a square. If it's a rectangle and a rhombus, then it's a square. Number 14, a parallelogram with congruent diagonals. Let's look at their theorems and see if we have anything about congruent diagonals. There was these two theorems. Oh, look at that. If the diagonals of a parallelogram are congruent, then a parallelogram is a dot, 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 dot. And is that all we're given on that one? That's all we're given, so that's all we can say then. Now in number 15, we have congruent diagonals, so you already know it's going to be a something, and also that it has congruent consecutive sides. Let's look at that theorem. Number 653, if one pair of consecutive sides are congruent, then the parallelogram is a... So we know two things. If you know two things, that it's a rectangle and a rhombus, then you can say it's a... If it's both of them, where is that? To prove that a given quadrilateral is a square, it is sufficient to show that the figure is both a rectangle and a rhombus. There you go. And you'll continue in that. You'll look up the theorems and see if it's enough to show it's a rectangle or to show it's a rhombus. If you can show it's both, it's a square. All right, so thank you very much. That's all there is for this lesson. Good luck, and please ask me if you have any questions.